Hello friends, welcome to GSR ChemTube channel. Here we are going to discuss about atomic structure chapter. In that, the ancient views about the atom and Dalton's atomic theory we are going to discuss now. Everything around is matter. Matter is made up of tiny particles called molecules, which can be broken down into simpler particles called atoms. The name atom was based on the Greek word atomos, which means indivisible. Ancient views about the atom. In 600 BC, Indian philosopher and saint Maharshi Kanada came forward with the idea that matter is continuous and made up of tiny particles named paramanus, which we call as atoms. Kanada further said that two or more paramanus combine to form bigger particles called anus, which are called as molecules. Chemist John Dalton proposed that matter is made up of very small indivisible particles. In 1808, he put forward his atomic theory, which can be summarized as follows. Let us see here the important postulates of Dalton's atomic theory. Matter consists of small indivisible particles called atoms. Atoms can neither be created nor be destroyed. That means we cannot create the atoms synthetically in the laboratory, or we cannot break them too. Atoms of same element are similar in all respects. Conversely, atoms of different elements are different in all respects. Atoms combine in small whole numbers to form compound atoms. We are calling them as molecules. Atom is the smallest unit of matter that takes part in chemical reactions. Dalton's atomic model became the basis of further research on the structure of the atom. But today, Dalton's atomic theory is almost discarded because of further discoveries. Here let us see what are the defects of Dalton's atomic model. Atoms can be divided further into subatomic particles like electrons, protons, and neutrons. So, by the discovery of these fundamental particles, electrons, protons, and neutrons, the point in the Dalton's atomic theory, that is, atoms are the smallest particles, is being failed. Nuclear reactions show that atoms can be created and destroyed. Here, the reactions in which two or more smaller atoms combine together to form bigger atoms, or a bigger atom splits into simpler atoms, two or more simpler atoms are called nuclear reactions. So in these reactions, bigger atoms are being created or smaller atoms being created. It means atoms are being created and destroyed. Such kind of reactions are called nuclear reactions, which is controversial to one of the points in Dalton's theory. That is, atoms cannot be created or destroyed. So that point is being failed. Discovery of isotopes proves that atoms of same element need not to be similar in all respects. Here, the word isotopes means the atoms with the same atomic number but different mass numbers. So, atoms of an element may be with one or two properties dissimilarity. For example, chlorine exists in two isotopic forms, chlorine 37 and chlorine 35. This shows that atoms of same element can be different in some aspects or respects. In this example, the mass number of chlorine in the two isotopes is being different. One kind of chlorine is having the mass number 35, whereas the other one is having mass number 37. So one of the properties of the atoms of same element are being different. So by this, one of the property of Dalton's atomic theory is failed. Next, discovery of polymers and micromolecules proves that atoms can combine in large numbers too. So a polymer is a very large chain-like molecule made up of small molecules. It can be naturally occurring or synthetic. So here, in making of polymers, large number of smaller molecules being combined, which is controversial to one of the points in Dalton's atomic theory. That is, atoms combine in small whole numbers ratios, he told that. But here, in the making of these polymers, small molecules are combining in large numbers. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.